Hello students, you must have balanced so many chemical reactions and you must be confident about that. But there is a trick over here. There is a bet. You try balancing this one and you will find that there is something special about this. See, let's try this. Sometimes students start with a very simple coefficient. Let's say try with a coefficient equal to 3 for carbon. So you can see 3 carbon and then you have this carbon monoxide. You make it 2. And then you have 1 carbon dioxide, and then you count O, then you'll find that it will be finally 2O2, right? You can see there are 4 oxygen atoms on these sides and other this side. So you see the coefficient 3C plus 2O2 gives 2CO plus CO2. Now let's try with another thing. Let's try with this 4 carbon, and let's do this. Make it 2CO as well as 2CO2. Then you count total number of oxygen on the right. Then you will come to this conclusion. It is finally equal to 3O2. Now you can clearly see the coefficients are 4C, 3O2, giving 2CO plus 2CO2. And these two coefficients are not the same. You see, one important thing about balancing is that it must be unique. That means even if you have different numbers, they must be in the same ratio or proportion. That's the rule of stoichiometry, right? Let's try something different. Let's try this. Let's try some 20. Let's put 20 carbon. And then you try to take, let's say 18 carbon monoxide. And then you take 2 carbon dioxide. Now you can clearly figure out that how many oxygen are there. 18, and then you have 422. Then you'll finally, surely you'll get 11 O2. You see there are 22 oxygen on this side as well as on this side. You can clearly see there is no limit to the balancing. See why it is happening like that. Why there are so many balancing in this chemical equation, which looks very, very simple like that. You see, there is a very, very important clue over there. This reaction is basically the combination of these two reactions. C plus O2 giving carbon monoxide. This will be clearly balanceable with a unique coefficient. You make this 2 and then you make this 2 as well. And there is one more balanced chemical equation hidden in this. That is C plus O2 giving CO2. Now you can clearly see these two balanced equations can be added into each other so many times, any number of times, to reach variety of balancings. So there is no law of constant proportion that is being followed over here. It is actually multiple proportion. That's why there are so many balancings. So you cannot balance such a chemical equation in which there are more than 2 ways of combinations of 2 elements. So that's the law of multiple proportions. So always remember this.